Right, so here we are, Kinesiology 230, and this is chapter 23. This is presentation 2, 2B, to be quite honest. And I froze this on the last presentation because there's a lot to kind of parse through on this slide, and I want to just focus maybe 10 minutes or so here. I mentioned previously that like when I calculate out quick and dirty 1 rep maxes for my clients, they get down on a bench and they do a bench press and they do 10 repetitions. I do 0.03 per rep. Now understand this. As we go ahead and look at the 0.03, when you get closer and closer to performing 2 reps or 1 rep, it's no longer 0.03. Like down here, if your client performed 1 repetition, it's actually more like 0.001 because it's as close to a 1 rep max as possible. 2 reps would be like more like 0.005, 3 reps, it's kind of curvilinear if you want to think of it on a graph or logarithmic. But where I'm going with this is mathematically, a person does a set of 10, you have 0.03 times your 10, which gives you the coefficient of 0.3. Got it. Well, we subtract that 0.3 from 1, that gives us 0.7. 0.7 is also known as 70%. So we know if a person does a set of 10, they're working at approximately 70%, give or take, of their 1 rep max. And I mentioned earlier when you do like multiple sets at the same repetition range, set of 10, set of 10, set of 10, you might do 70, 70, 65 or 70, 70, 68 because of the fatigue factor, but just realize you're working within the context of a range. Now, we didn't really talk a ton about downloads, but in the context of working out and training in a mesocycle, you'll have weeks where you download the loading parameters, meaning what the actual weights are that you're doing. And it can be you drop the number of repetitions, so the volume drops, or you drop the actual weight itself, so the total volume load also drops. Either way, the total volume load does drop. I'm sorry to say I said that kind of backwards. Either way, the total volume load does drop mathematically, but on one side it's because of the repetitions, on the other side it's because of the actual load or how much weight you're throwing around. So you might do sets of 10, for example, instead of being 65 to 70, you'll be at 45 to 55, just a little bit lower. With Olympic weightlifting, it's a little bit different. You even skew this a little bit more because like with Olympic weightlifting, you might be in the middle of a teaching progression and you still want them neurologically hot. So you'll be in the 4s, 3s, and 2s. But instead of doing 85 to 90, you might be more like the 75 to 85 range. So you have enough load, so you have the myo side working, but you still have the nervous system firing at a very, very high efficient rate, as opposed to trying to do just sloppy bar work. You have to have a little bit of load in the equation. So I'm going to jump out of this and go over to the right-hand side. On the right-hand side, and I've talked about before, and I've used these numbers, so it should be pretty straightforward, but now you can kind of see it laid out in a mathematical equation. If we have a client who did 140 pounds on an exercise and they complete 10 reps, the coefficient of 0.03, we multiply that by our 10 reps, that gives us 0.3. We subtract 0.3 from 100, that gives us 0.7. That's what we saw over here. 0.7 is also known as 70%. So if we look at this and we go, okay, 200 pounds times 0.7 would give us 140 pounds. It's a lot like gymnastics. You're just tumbling forward or tumbling backwards. You can go ahead and go, well, my client did 140 pounds. I'm going to divide that by 0.7. That's going to give us a floating max of 200 pounds. So if you are able to do a little bit of math on the spot, you can literally tell your client right at that moment, based on what you just did and the number of repetitions you did it, your max is 200 pounds. Simple. Now, if we go ahead and look at this in another context, and you ask your client to do 140 pounds, and they say, I'm going to do 145. And they put 145 pounds on the bar, and they do it 10 times, a lot like up top here. And we go 0.03 times 10, that gives us 0.3. So they're still at 70% of the 1 rep max. Because they did 5 pounds more on the bar for the same volume, meaning 30 repetitions total, or in this case, if we just use one set, it's 10 repetitions, your 1 rep max is now calculated out at 207. So just by adding a little extra weight, you can mathematically show your client that they got stronger. It's not like they magically got stronger on the spot. It's just the fact that you can show mathematically that they're getting stronger as they go through their workouts. Interestingly, we can do the same math down here. If we use 140 pounds, right? So a lot like up here, we're doing 140 pounds, but instead of doing 10 repetitions, we do 11 repetitions, and we go 0.03 times our 11, that gives us 0.33. And that means when we go 1 minus 0.33, they were working at 67% of a 1 rep max. Now it's 140 divided by 0.67. Their calculated 1 rep max is 209 pounds. So they're both pretty close. They're within 2 pounds of one another. And this is where it becomes important. Like when you're talking with your clients and you say, I want you to do sets of 10, and they pound out 12, you know you got the wrong weight on the bar. You can go a little bit heavier with them. But you can also show them mathematically, hey, I based your sets of 10 off of a 200-pound max, and you just blew it out of the water by 20% because you did 2 more reps. Your new max is actually X. Or in this case, your new max is now 9 pounds heavier than I originally thought. It's not 200 pounds, it's closer to 209 or 210. Great job. How that flows through is when you have multiple week workout sessions, and say like your first week is 3 by 10, second week is 4 by 10, then we go 3 by 8, 4 by 8, 4 by 6, 5 by 6, 4 by 5, 5 by 5. Pretty linear kind of program here. And they have a 200-pound max. If we just did straight line programming, 70% times 200, it would be 140. 70% by 200, 140. 75 would be 150, 75, 150, 78, 156. You get the idea. They would still show the 200-pound max, right? But here's the thing. Your client comes in on the first workout, and we have 140. That is the workout weight that is assigned to them, but they do 145. And this is very reminiscent of what we saw right here. Well, we know that max goes up to 207. All right. And so now they're assigned 145 for 4 sets of 10. The volume is higher, so we know the total volume load is higher, so there's greater work here. And they do their 145 and they nail it. So we know that this is valid. 207 is proper. Well, we go up here, and based off of 207, now it's 75%. Instead of doing 150 pounds, they're assigned 155. And they're feeling good. They do 160 instead. We now know that their max is actually 213 pounds. They come in the next workout, and they have 4 sets of 8 instead of 3 sets of 8. That's still 75%. And we base it off of the 213 that we just calculated out. And they do the 160 pounds. We know their max is actually 213. This is a valid floating max for the person. Replicate that down the line. 4 by 6, 5 by 6. We base the workout weight of 166 off of this number, the 213, and they actually do 170. Well, their max just went up yet again. And then we get into 5 by 6. We ask them to do 170. They do 170. Max is validated. So you can use, from a week-to-week standpoint, a way to incrementally increase max as your clients either push out 1 more rep or add 5 pounds. And then you can use the next week and ask them just to do the actual reps that are assigned to them. And you can do that as a way to validate the actual workload, or the actual maximum that you've calculated out. So if we take this a step further and we go to our 4 sets of 5, we assign 185 for a workout based off of this 218. That's the 85% of 218, and they do 190. Well, their max is now 224 pounds. It becomes validated again the next week when they nail the 190 for 5 sets of 5. They're at 224. So what we're seeing here is, instead of just following along and doing the weight that's prescribed or assigned, if they add just a little bit of weight kind of randomly throughout their workouts, they're no longer a 200-pound bench press, they're a 224. Mathematically, we can show it. And if we just kind of randomly throw in, instead of a set of 10 here, like we want to do 4 sets of 10, they do 11. Or instead of doing sets of 8, they do 9. Or over here, instead of sets of 5, they do 6. The math flows through yet again. Just, I'm not going to bury you in all the details, but we can do the same math in terms of the coefficient divided by the weight that was used. And what we see here is, at the end, instead of being a 200-pound bench press, they have a 223. They're almost benching 2 plates on either side. So my point to you is when you're working with your people, whether it's your athletes or your clients, you can guide them to, in the context of what you're doing, okay, for these 3 sets of 10, I want you, if you can get a couple more reps, go ahead. If you can do an extra 5 pounds, go ahead. But that's going to be a feeling out process as you kind of work them towards that floating max. And remember the chart that we saw before where you have this big gap on the front end between their absolute genetic potential and where they're starting off. It's a big gap and there's a lot of room in there to grow. And you have to be adept at creating programming that allows your client to grow in a systematic manner, but doesn't blow them completely out of the water or perhaps set them up for injury. All right, guys, I'm signing off. That's my 10-minute mark. Have a good one.